This video is about a recent innovation to an established building technology which will enable poor people in rural communities and displaced people like refugees to provide themselves with effective shelter, water storage and sanitation facilities. The machine in question produces stabilised blocks for building which do not need firing and which can be made on site using subsoil commonly found throughout Africa. Traditionally, houses in Africa were built using clay and wattles. For hundreds of years, these have served as the primary building materials used in house construction all over the continent. But things are changing. About 20 years ago, clay-fired bricks arrived on the market. These are handmade, dried in the sun, and then fired in huge kilns that can be seen lining the roads all over Africa. In spite of their growing popularity, these bricks have severe limitations. They are uneven in shape and require lots of mortar to construct a good wall. They also have to be transported from where they are made to the building site, with many being damaged in transit. The low quality of these clay-fired bricks also means that they cannot be used in other applications, such as sanitation projects or water storage. The clay is dug from wetlands which are drained and then excavated. Using a wooden mould, the bricks are formed and then left to dry in the sun for several days. Once dry, they are carried to the roadside and made into piles, often containing as many as 15,000 bricks. The sides of these piles are plastered with wet clay to keep the heat in, but they are far from efficient. Most damaging of all is that they have to be fired using tons of increasingly rare tropical hardwood. In all, the process usually takes about 3 months, and the finished product is often cracked, misshapen, or unevenly fired. Not only do these bricks provide poor and expensive building materials, but their manufacture has a disastrous environmental impact on Africa's dwindling hardwood forests and wetlands.
Enkutu zijja mukono kabembe maironga 8 15 bwezityo kisinziira ku lole gye tuba tufunye. Tufuna lole nnene emitwalo 15 taninga 5. Ezitanulu ngene egenda mu lole 4 ziri lole 4 z'emitwalo 8.
In countries where it can be difficult to find work, brickmaking has become something that anyone can do as long as they have the raw materials.
Ekintu ekizibu ennyo kujja ttaka wansi eyo okulituusa waggulu n'ekyokubiri kyanku kuba enkunzibu nnyo mu kugula kwazo ate n'amaanyi g'okozesa kuba kati wano enkuba ng'etonnya oba tosobola kulisambira wansi wabula oba olina kukwata kitiiyo n'olitiya ne lidda waggulu.
The fires are kept burning for 24 hours, often with new wood being added. Although only a fairly recent phenomenon, brickmaking of this type has already had an unsustainable impact on Africa's forests.
Tanulu kati nga weeri awo oyinza okugifunamu kale amagoba ng'oggyeko byonna sente z'okozesezza oyinza ofuna amagoba mitwalo nga 10 noba ng'osobola ate okwongera.
The phenomenon of firing bricks is relatively new. It's probably in the last 15 to 20 years that people discovered that you could actually make bricks cheaply without compressing them and then fire them, and then you would use them to build houses. And of course that required vast quantities of firewood. The problem of deforestation in Uganda is a serious one. We used to have vast hardwood forests, what we used to call tropical forests or rainforests, but most of them have been felled, they have been cleared. Desertification is with us. It's now known that the Sahara is moving southward at a rate which I think some people estimate at 20 kilometers per year. So if we keep cutting down trees, the other consequence is desertification, because we'll have no rain, the soils will be washed down, and what will remain are the bare rocks, or whatever little there is will turn into sand.
Uganda's population is currently estimated to be over 25 million. By 2050, this figure is set to rise to 100 million. To accommodate this vast increase, Uganda's housing strategy will have to change significantly. With deforestation already a major issue and the demand for new houses already rising rapidly, a new approach to brickmaking is urgently required. The Stabilised soil block press has been manufacturing building materials in East Africa for over 20 years. It is a proven and appropriate technology designed and built in Africa and developed for African conditions. Weighing just 130 kilograms and requiring very little maintenance and training to operate, the soil block press can provide block-making capabilities to anyone, anywhere. Using the subsoil common throughout the continent and between 5 and 10% cement in order to stabilize the mixture, blocks can be manufactured quickly and easily for use in dozens of applications.
So the first thing we do is to fill up the mold box with the prepared soil, which is a mixture of cement and the soil with a little bit of water.
For the past 15 years, Dr. Muzazi of Makerere University, Kampala, has been developing stabilised soil block technology to meet the growing need for appropriate technology solutions to the housing problems faced in Uganda and elsewhere in Africa. Using his stabilised soil block press, Dr. Muzazi is able to produce blocks that are stronger, better made and longer lasting than clay-fired bricks. As there is no need for wood firing, the manufacture of these blocks represents an enormous saving in the use of wood.
This block is strong enough to be stood on, and I'm going to do exactly that. I'm going to, with my 92 kilos, I'm going to stand on it and see whether it will collapse. The block which we make takes only 5% of cement, and that's very little stabilization, but it is good enough stabilization because we have made tests and that block is going to be weatherproof in that you can put it in water for as long as you want, take it out, dry it, and obviously it will be usable. It will not disintegrate because of the water, which means that you can subject this block to an amount of water after it has been cured. The machine is manual in that there is no engine or any aid whatsoever. It requires simple maintenance using used engine oil. 2 men who are experienced can make between 500 and 700 blocks a day. And the day we are talking about a day of 8 hours. And that is from soil preparation to making the blocks. If we give an example that a 3-bedroomed house will require between 5,000 and 7,000 blocks, within 10 days, 2 people will have made enough blocks for such a structure. Our experience and research has shown that all types of soil in Africa can be used. The only thing one has to remember that it has to be devoid of a lot of clay. The more clay there is, the more cement that you have to use in order to stabilize it. But the soil you find in anywhere, in any compound, on any hill and anywhere can be used, as long as you remove the organic materials. The top black cotton soil, that one must be removed for one reason only, that it contains decaying organic material. And once you remove that one, anything underneath that one is what we call the subsoil, can be used for making your blocks.
Field tests conducted by GTZ concluded that dry compression strength using these stabilization ratios were all in excess of the required minimum. As the technology has been developed, it has also been improved. To achieve greater strength and cost efficiencies, Dr. Muzazi has introduced the interlocking soil block and the curved interlocking soil block. These require less mortar and enable stronger structures to be built for less money. The curved blocks that interlock on all four planes are the latest innovation. They represent a unique breakthrough in the provision of affordable water storage and sanitation systems.
This technology is perfect for building latrines. There are situations where the soils are so loose that when you dig a pit for a pit latrine, the walls will collapse in or cave in. We are demonstrating here a situation where you can dig a pit in the normal way, but line it with our interlocking stabilized soil blocks, such that you end up with a strong wall which is reinforced. Especially in cases where the walls, the natural walls can collapse in or cave in, especially in sandy areas. We are saying here, by reinforcing them with our ISSBs, we can actually build a pit latrine in the normal way. This pit latrine will last much longer because the walls are reinforced, but two, if need be, it can be re-emptied. I'm standing over what we have constructed as a pit latrine, which is constructed from underneath. And if you look carefully, it's not a perfect circle. And we're saying that that's no problem, because somebody may be a learner, somebody may have made a mistake on the measurement or construction, but it doesn't matter. At the end of it all, the blocks have interlocked into each other. This is good enough to show that you can get away with some errors, but they will not be detrimental to the structure itself. This pit latrine was started not in the morning, but a few hours. We have been at it for the last, let's say, 3 hours after digging the pit. It has got a diameter of 1.5 meters and got a height of the same. The height is about the same. And we are saying that from morning to this time, in a total of about 4 hours, we've been able to construct this pit latrine. It has got the number of blocks, 10 layers, 10 blocks per layer, and 10 layers. So with 100 blocks, we've been able to construct this. And 100 blocks is actually 1 bag of cement. And so we are saying with 1 bag of cement, one is able to construct a pit latrine. The fact that the curvature or the curve of our blocks is limited does not mean that the diameter of the water tank will be limited. What you do is to play around with the interlock, and therefore you can have a narrow container or cylindrical container, or you can have a very wide one by simply playing around with the interlock.
The diameter of the pit latrine or water tank can be altered by adjusting the angle of the interlock.
We have added a plaster course, a lining in the pit latrine, such that the internal walls are protected even further, so that it can be re-emptied and used again. So therefore this pit is not only are stronger than any other, but it is reusable. By simply using a quarter of a bag of cement, we've been able to plaster the inside of this pit. The next thing we're going to do is actually to slide a slab on top of this one. It's a precast slab which has got a hole on it, so that after sliding it on, the pit is ready to have the walls built on top. Then the next thing we shall do is to backfill the holes here. We're going to backfill in here and have the whole thing looking like a neat, solid stuff for using as a pit.
It is also possible to build multiple latrine stances using a single hole.
There is an advantage of having a big hole where you're actually constructing a pit latrine but with a big circular hole, because then instead of having one stance, you can end up with 4 stances by subdividing the hole into 4, just like this. Just imagine this is your big hole. Then you put a concrete slab on top of it, and then you subdivide that into this, and therefore you're going to have your hole there, your hole there, your hole there. So you end up with the 4 stances from one hole.
The curved interlocking blocks are designed to construct affordable water tanks above and below ground. Below ground, tanks of up to 40,000 litres have been built.
It rains quite a lot in Africa, and if you harvest the rainwater, you actually end up with water free of charge and at home. Water provided at home can be the biggest advantage of the entire family. This water is not only clean, but is cool. In the hot weather of Africa, if you've got cool water, you actually have gone a long way in solving domestic problems.
When transport and maintenance costs are taken into account, savings of up to 50% can be achieved over the plastic water tanks that are on the market. If the straight interlocking blocks are used alongside the curved interlocking blocks, this technology can provide a complete range of building materials to satisfy basic accommodation and sanitation needs.
I'm seated in a sitting room, as it were, which is basically 2 meters wide and 3 meters long. And that's all they've got. Of course, you can see the floor. It is basically soil, compacted soil, which has been trodden over years and years. The walls are almost falling apart. When you consider the years of the house, 70 years is a long time. But nonetheless, not being able to move from this structure to a better one is a helpless situation. Helpless and hopeless. You would imagine about at least 80% of Ugandans live this way. This may look very poor indeed, but definitely the picture is duplicated all over the country. The majority of Ugandans are poor, living in such conditions. I'm standing in front of a house which was constructed possibly 70 years ago. It belongs to 2 ladies who are obviously widows, and they have a number of grandchildren whom they have to look after. Before this project took place, they had no hope of getting anything other than what they have. This was their residence, and to my right here is the kitchen.
Ne batuzimbira ennyumba nebeera awo neerwawo nnyo nga tennaba kuyingirwa nga bagamba nti mulinde tujja kujja tuyingire tubalinda nga situbalaba twalaba nga tulemereddwa ne tuyingira
kati obulamu obusanga otya kasookanga ovaayo
kaka tuli balwadde awuli amagumba ogalaba tuli balwadde liko amagulu ago bwati bobi siba waka ate ne munnange naye mulwadde.
We are now moving from this old house to the new house, and I want to show you the difference it has made to the two widows in terms of quality of life and better facilities. This is the main house. We have designed it in such a way that there is a small veranda where one can sit during the day or evening when the sun is hot. There are wooden windows. They can be duplicated in the village. We have left here a window, a small window, to show that this house was constructed using our interlocking soil blocks. Because after years and we've done the plastering and we've done the rough casting, maybe somebody won't believe that it was done.
Nenyumba nnungi nnyo okusinga ennyumba gye twalimu kubanga ennyumba enkuba ne bwetonya tubeera bulungi, enkuba tetukuba. Naye ate ennyumba gye twalimu enkuba yalinga etukuba ate nga n'empewo etufuuwa nnyo.
Just make sure that there's enough ventilation, which of course the old house didn't have, that we provided enough windows on the sides of the house. There are ventilators up there. You get to make sure that the house is airy. And of course, if you open it up, you don't need any light other than the natural light during the day. If you look over there, we have provided gutters so that you can harvest the rainwater from the roof into a tank here, which is 4,000 liters. This water tank was constructed using interlocking stabilized soil blocks, but the special ones that actually curve and interlock into each other, and when you do that, you end up with a circular structure or cylinder or cylindrical water tank. Of course, it's plastered inside, and the outside is simply to make sure that it will last longer. But it's magical in a sense that the ladies here, they're old women over 80 years old. They have children, some of them are dead, but they have little grandchildren. These ones would have to go and fetch water from the well or from somewhere else.
Ate munaffe Museveni n'atusemera enzizi n'atuwonya ate kati wetufunidde na luno enkuba bwetonya tukima sana pegwaka netugenda ku nayikondo.
At the end of it all, one would want to know how much does it cost to construct this house, a water tank, a pit latrine, which includes a bathroom. The total cost for this is about $2,000. And that's exactly what was spent to construct the three structures. They're very vital: a home, water, and of course the pit latrine and the bathroom. It is that cheap if you use the technology we're talking about. Please remember that the materials that were brought here was only cement. The rest, the soil, was dug from a pit around here, and the house was constructed.
In a recent school building project, cost analysis has shown that savings of up to 18% are possible. Using local materials and local labour is a vital aspect of the implementation of this technology, making it accessible to those who need it and sustainable over the long term. One machine can be used to manufacture enough blocks for an entire community's building needs. All of these water tanks at Luwera Kasana, outside Kampala, were built using one machine. There are over 500 in all. As well as providing building materials, the machines create opportunities for community participation, skills training, and income generation.
It is always thought that solutions that are imported are actual solutions, imported from outside Africa to solve the African problems. I would like to state very strongly and clearly that this is not true, because after a while these solutions are not sustainable. And sustainable in a sense that you can have a high-tech machinery that is going to last for a while, but requires maintenance and spares and human resource, which you cannot afford to do. The solutions that are to African problems must come from within, must come from us, the Africans, to solve the African problems. And they must be found right here, not from outside there.
Africa's development is threatening its future. As the population grows and the demand for accommodation increases, the environmental inheritance of an entire continent hangs in the balance. With recent objectives such as universal primary education poised to put additional pressure on the demand for building materials, Africa's exploding population needs sustainable and affordable solutions now. The adoption of appropriate technology such as interlocking soil blocks and the manual machines that produce them must be made a priority.